Hi everyone, Mr. Markwick here. Today's video I'm going to show you how to calculate probabilities using a graphics calculator when data is normally distributed. So in my previous video, the normal distribution curve, we looked at using the 68%, 95% and 99.7% rules to determine the probability or the percentage of data that would fall between certain values. But those values were whole standard deviations above or below the mean. Okay, so today we're going to be looking at values that don't fall on whole standard deviations above or below the mean. And how do we use our graphics calculator to find those? Okay, so let's just jump straight into the example here where the variable x is normally distributed with a mean of 40 and a standard deviation of 10. So I'm actually going to draw that really briefly. I'm just going to sketch that graph just so that we can sort of see it visually a little bit. So apologies for this. I'm a bit wobbly at the moment. For some reason, my straight line's not working on OneNote. But in the middle, I'm going to put my my mean. So that's 40. And there's going to be 3 standard deviation steps below and 3 standard deviation steps above. Each will increase or decrease by 10. So above it would be 50, 60, and 70. And below it would be 30, 20, and 10. And that then would, I guess, set the parameters for my curve. Okay, again, it's just a rough sketch. The question here says, what is the probability that x is between 37 and 48? Okay, notice that 37 and 48 are not a whole standard away from the mean. So I'm just going to shade roughly in where we're talking about here, between 37 and 48. So 37 approximately would be kind of here-ish, and 48 would be here. Okay, so we're talking about if we selected a random data point, what is the probability it would fall between 37 and 48? Okay, so on our graphics calculator, I'll show you how to do that right now. We're going to use the stats function. Head into that, and then we're looking at distribution, so F5, normal distribution, so F1, and then for the sake of this video, we're using the F2 function here, which is the normal cumulative distribution. Rather than, and this is important here, so we don't have data that's put into a list, okay, and it will work out the standard deviation for you. We're actually going to put in a mean and a standard deviation because that was given to us here in the question. Okay, so change that from list to variable, okay, and that will then allow you to put in a mean of 40, okay, that mu symbol there, and a standard deviation of 10, again, that lowercase sigma symbol. So those values are now set. I'm going to work out the probability that a piece of data is between 37 and 48 based on that standard deviation and that mean. So I'm going to set my lower boundary as 37. I'm going to set my upper boundary here as 48. Once I've done that, I can then scroll down here and press execute to calculate that. What I like to do is I like to see the picture as well. So if you press F6 to draw it, it gives you a little, I guess, diagram or picture of the section that we're talking about, and it also gives you the probability down here. So the probability that a data point will fall between those two values is 0.406. So the answer is 0.406, which means 40.6% of the data falls between 37 and 48. Okay, so if you have two boundaries, a lower and an upper, you can just pop those in and go from there. It's a little bit different if you have no lower or no upper boundaries. So the process will look like this. What I'll do is, again, I'll just quickly color in the section on the normal distribution curve that we're talking about. We're looking at what's the probability that a data point is greater than 45. So 45 is about here on my normal distribution curve. What's the probability that if I select a data point at random, it's going to be above 45, okay? Well, it's obviously going to be less than 50% because it's not quite halfway, but what is it exactly? On my graphics calculator, I already have those parameters set in terms of the mean and standard deviation here. I'm just going to change the boundaries. So now I have a lower boundary of 45. That's my lower boundary. I can just put in 45. My upper boundary, I want to set that as high as possible. I want to make it as close to an infinite as possible. So we're just going to put in 1 times 10 to the power of 99. And that's my upper boundary. Okay, it's almost an infinite value that I'm putting there. So if I again scroll down, ask the calculator to draw that for me, I can see that, yep, that's the section I'm talking about. And the probability is 0.30, let's round that up to 9. So 0.308 or 309, which means 30.9% of the data is above 45. Okay, last one here is, again, very similar, but this time it's asking what's the probability that a value is less than 26. So less than, approximately kind of here-ish. What's the probability that a data point will be below 26? Again, in my graphics calculator, I already have the parameters set in terms of the mean and the standard deviation here. I'm just going to change the boundaries. So now my upper boundary is 26. And my lower boundary, I want to make really small. So I'm going to go change that to negative or minus 1 times 10 to the power of 99. Really important that you put that minus in, because if I don't put in at minus 1 times 10 to the power of, if I didn't put in the minus 1 times 10 to the power of 99, then it's not going to be able to calculate a value for me, right? Because the lower boundary would actually be higher than my lower boundary. Anyway, just make sure when you're setting a lower boundary, you put it in as a negative amount, and when you're setting an upper boundary, you put it in as a positive amount if you're not given those lower and upper boundaries. So again, what is the probability that that's going to happen? Ask it to draw it for me. Great, that's the part of the normal distribution curve I'm looking for, and the probability is 0.08. Let's round that up to a 1. So probability that a piece of data will be less than 26 is 0.081, which means approximately 8.1% of the data is less than 26. Okay, so it really is as simple as that. Make sure you understand how to use the graphics calculator to determine probabilities using a graphics calculator. Really, I guess the only trick here is making sure you put in the standard deviation here, okay, with this lowercase sigma symbol, and your mean here with this mu symbol, and then setting those boundaries correctly dependent on what the question is asking. All right, so that's it for this video. Hopefully it helps, and thanks for watching.